Hi folks, we're in the final stretch now. Well done to all those of you who have been revising along at home. We'll start with Foundation Plus as per. First thing we want to do is expand a pair of double brackets. We all know that we need to multiply each term on the left by each term on the right. Collect the terms together, w squared plus 13w plus 36. For the second question, it is a bounds question. It says it is rounded to the nearest 10, and remember you should be thinking HAT. That is halve that, so 10 divided by 2 is 5. Add that to 250, that gives you 255. Take away, that gives you 245. The other thing to bear in mind, I think we said this yesterday, possibly the day before, is the inequality should have a equal to on the left and not on the right. That's because 245 exactly would round up to 250, but 255 exactly would round up to 260, so we can't have it. Okay. Next up, we got a nice little SOHCAHTOA question. First, obviously, make sure you get your angle right. ABC is the angle you get when you drew a line from A to B to C, so it's this X angle here. Label your sides, adjacent and hypotenuse. We're going to use cos, so that's cos minus 1, 12 over 13, 22.6 degrees. This is a non-calculator question. Obviously, it's quite easy to do it with a calculator, because you just add the numbers up, but this is checking whether you can add fractions. Now, I tried to do this the straightforward way, and the straightforward way for me is to add up the fraction bits and the whole number bits separately and then put them together. So I needed a common denominator for 2 and 3 and 5, so I just multiplied them all together to get 30. This means I've got 15 out of 30 instead of a half, 20 out of 30 instead of 2/3, and 6 out of 30 instead of 1/5. So I've times them by 15 and 10 and 6, and remember you do need a common denominator before you can add fractions together. Then we've got 1 and 1 and 2 make 4, and 15 and 20 and 6 makes 41 over 30, which is 1 and 11/30ths, so overall 5 and 11/30ths, fully simplified. Units, I guess, would be miles. Okay. Last one, just some vector addition. You multiply the first number by 3, so that's 9 minus 3. The second number by 3, 3 minus 6. Add the tops, add the bottoms together, 12 minus 9. Okay. So let's push on to higher. So, first question, I've got two options for how to do it, but this is a quadratic equation. And what do we have to do first to solve any quadratic equation? We need to make one side equal to 0. So that means we're going to need to expand our brackets here, which overall simplifies to x squared minus x minus 2. And we're going to need to subtract the 40 to the side as well. So that will give you overall, so we've taken away 40 here, x squared minus x minus 42 is 0. That is like the first step of any quadratic. You need to do that to start. Then you've got two options. You can factorize this. Times is to minus 42, adds to minus 1, that's minus 7 and 6. And don't forget to flip your signs for the actual answers, or you could use the quad formula, which would also give you 7 and minus 6. But that whole get one side equal to 0 thing, that is absolutely crucial. Okay. Then we've got a couple of surds. The first one is just, well, they just times together, it's root 30. And the second one, I wrote this out as root 3 times root 3 times root 3 times root 3, because there's 4 of them. And then times 2 of them together at a time. So that gives me 3, that gives me 3, and now 3 times 3 is 9. There are other ways of visualizing that, I think, but that way made most sense to me. Another way would be to have it as like a power. So we know that 3 to the power of half is the same as a square root. So that's 3 to the half to the power of 4. Multiply those two things together, so a half times 4 is 2. And then we could get 9 that way as well. Either way. Next we've got circle theorems. So final answers are on the left hand side, but again make sure that you know the names of all 6 of the circle theorems you need to go in with. That is double angle, same segment, semicircle and right angle, cyclic quadrilateral, alternate segment, and tangent plus radius. You do need to talk about them. In this case, A is 81 because this is an isosceles triangle, because we've got these little lines on it. Y is 18 because triangles add up to 180. And then X and Z are both alternate segments, as in if you turn your head, I suppose, 90 degrees. Z, bottom left, A, top right, and X, bottom right, 81, top left. Okay, and then finally, we've got an interesting little gradient problem. So we've got 2 points here. We've got 3, 1 and 8, 11. And the gradient between those 2 points is 5/2. Now, one way of doing this question would be to find the equation of the line and then substitute back in the point B to it. But I think that's actually probably more complicated than you need to do. But we will go through that way as well. The way that makes sense to me is to think about, well, what is gradient? Gradient is change in y over change in x. And we can almost see this on the graph already. We can see the change in y is 10 because it went from a point 1 to a point 11. We can see the change in x is a minus 3 because it's x2 minus x1, you could think about it. And that's equal to 5/2 because we're told that's what the gradient of the line is. So we set those two things equal to each other, and then I just doubled this one on the right, well, times the top and bottom by 2, so it's not really changing its value, to make the 10s the same, and that means that the bottom were the same as well. So a minus 3 is 4, so a is 7. The other way we could have done that one is we could have found the equation of the line using y minus y1. So we could have had, like, this is our x1, this is our y1, this is our m, and we could have said y minus 1 is 5/2 x minus 3. I guess we could have then expanded that. So y minus 1 is 2.5x minus 7.5, and added the 1, 2.5x minus 6.5. So we could have done that to find the equation of the line AB, and then we could have put this point into it. So we could have said, so y is 11 is equal to 2.5a minus 6.5, so 17.5, yeah, we'd have to add that, is equal to 2.5a, and then divide by 2.5 to get a is 7. So that is another way we could have got to there, but for me that's more complicated. Definitely an option though. Okay, and then higher plus. Classic scale factor question to start with. The thing you've got to know is basically that if we talk about weight, such as this, 108 grams, weight is volume as far as scale factor is concerned, because they're both to do with filling the 3D amount of space. Also, we've got this word similar, which means they're just enlargements of each other. Smaller model is 15, larger model is 20, so we work out the length scale factor, dividing one by the other, 4/3. And then we work out the volume scale factor by cubing that. Remember, if it was area scale factor, we'd need to square, but it's volume scale factor, so we cube. And then we multiply the volume of the small model by that to get 256 grams, which is a nice whole number. You'll notice I've kept these as fractions rather than decimals. That just means you make less rounding errors. If you'd written 1.3 here, you'd be a little bit off by now. This is a completing the square question, and it's a little bit of a while since we've seen one of these. So this is the formula for completing the square, and that means whatever you've got here, whatever number you've got in front of x, you halve it and put it in these two places. When you think about splitting it apart, put one part here, one part here. So we've got 6x in this example, so these become 3 and 3. But it's not just x squared minus 6x, it's x squared minus 6x plus 17, so we need to add a 17 on the end. So minus 9 plus 17 is overall plus 8, and that's done. Okay, this was, I think, probably the weirdest question here. Yeah, probably. So we've got cylinder and sphere have the same volume. We need to know that a cylinder volume is base area times height, and you generally get told the sphere volume if it's required in the GCSE these days, so that's 4/3 pi r cubed, and those two are equal to each other, so set them equal to each other. You then need to look at the diagram carefully and think about what represents what. So on the cylinder, the radius is 6y, because that's half of that 12y. The height is 9y. So we put all of that into our cylinder equation. So pi times 6y squared times 9y. And the sphere volume, it's just radius is r, so we can't do anything about it. Next thing I did was I cancelled out the pi's, so you can think about it by dividing both sides by pi. Because we don't want that. We want just this to be r equals, because it says r in terms of y. And then I tried to simplify the left. So if you square 6y, you don't just square the y, you square the 6 as well. So that's 36y squared. Times 9y, so that's 324y cubed. So on the right I've just got 4/3 r cubed. And then to get to the next step, I divided by the 4/3. to get to 243 y cubed, which is what r cubed is, and then to finish it off you need to cube root that to get 6.24, because that's the cube root of 243, y, because that's the cube root of y cubed. And there you go. That's r in terms of y. Couldn't really think of another way of doing that one. Okay, finally we've got a quadratic simultaneous equation. This looks fiddly, but it ended up being quite nice. So when you've got a quadratic, your first hope is that they both say y equals, and you can just sub one into the other one. But this doesn't have that. This has x squared plus y squared on one of them, and it has x and y on the other. So we need to change one of them to be x squared equals or y squared equals. Now I went with x squared equals, but there's no reason that you couldn't have done y equals a half x minus 3, and then y squared is a half x minus 3 squared, and worked that out and then substituted it into the top one and got the same answers. The reason I didn't do that was that I didn't want to have to square fractions, essentially, because that would be a half x that I have to square. Whereas if I just double this bottom one and get to like x is 2y plus 6, that's easier to square because it's whole numbers and it's all positives. So it's purely a laziness issue, as it always is in maths. So I squared that. 4y squared, 12y, 12y, 36. Add the two 12y's together to 24. And then, because I know that's what x squared is, I can put it here into the equation. Let's just get rid of this. So instead of saying x squared plus y squared, I could say what I'd worked out x squared was. So 4y squared plus 24y plus 36 plus y squared equals 36. And the good thing about that is that, again, it's a quadratic. You make one side equal to 0. The 36 is completely cancel out, and you end up with 5y squared and 24y. Now, that can trick people because they forget that if you can just take out a common factor of everything, you can just do that. So y is in both of these terms, so you can just put that outside of a bracket, and 5y plus 24 inside the bracket, and then we're basically done. So this gives us y equals 0, and this gives us, change the sign, divide by how many y, minus 24 over 5, or minus 4.8. And then if we substitute them into, I think I substitute them into x equals 2y plus 6, because I worked that out over here. 2 times 0 plus 6 and 2 times minus 4.8 plus 6 gives me my last two answers. So those are my solutions, 0 and 6, and minus 4.8 and minus 3.6. Okay folks, hope that helped. See you tomorrow. Cheers.